we're trying to solve our trig equations, okay, we're going to be using our unit circle. So if we don't remember our unit circle, you're probably going to need to refresh yourself on the unit circle. And we want to get something like sine equals 1/2. Cosine equals square root of 2 over 2. Okay, that's going to be our goal. In order to do that, we're going to have to first get the trig function by itself. And we do that just using our normal like algebra stuff, right? We can combine like terms, we can factor, we can also like add, subtract, multiply, divide things as needed as well. So if we looked at something that looks like this, again, our goal is to get the cosine by itself. Because once I do that, just like we did for other two, we can use our unit circle to kind of work our way backwards. So right now, is my cosine by itself? No. What do we have with it? A 2 and? Yeah, so what do we need to do first? Yeah, so remember order of operation tells us that I do parentheses, exponents, multiplication, division, and addition and subtraction. That's when we're simplifying. When we're solving, we have to go in the opposite order, so I have to get rid of subtraction and addition first. So since it's already negative, we are going to add it to both sides. And then we said that we also have a 2, so how would we get rid of that 2? Divide by 2. Do we get something that looks like that? And the reason we want to isolate that is because there's not really anything nice that undoes our cosine, and so we can't like divide by a cosine or anything like that. So once we've gotten to this point, we then use our unit circle to work our way backwards. So we're saying what angle for x, because we're still trying to solve for x, that's our goal. So what angle for x gives me a cosine of square root of 3 over 2? Over 6. And remember, we're usually going to have how many spots on our unit circle where it equals that? 2. Most things are going to have 2 spots. So what would our other angle be?
11.5%.
Okay. Why that one? Besides just if I was just looking at my unit circle, how do I know that one?
Did you say we need to put 2 down?
Yes.
Okay.
Unless it's a quadrant angle, so like if you get like pi over 2, pi, 3 pi over 2, or 2 pi, those are only going to have one answer for some of them, but all the rest of them should have 2 answers. At least 2 answers. So how do I know it's in my 4th quadrant? Cosine's positive, right? So notice that we have a positive value here, right? So I need my cosine to be positive. Our cosine is the x value, so that would be in my 1st and my 4th quadrant, right? The other way, remember, is A smart trig class. So these things, these are where we're positive. All of our trig functions are positive in the 1st. Sine is positive in the 2nd. Tangent is positive in the 3rd, and cosine is positive in the 4th. Yes, no, maybe? Okay. And we also know that it's gonna, if it's pi over 6, it's gonna have a reference angle of pi over 6. So in my 4th quadrant, the angle that has a 6 in the bottom is 11 pi over 6. So let's look at that. Alright, I want you to try this one on your own. check with the neighbor. See if y'all got the same angles. It looks like most of us were able to get to, I subtract 4 and divide by 8, which is going to be a negative 1/2. And then double check and see what y'all got for your angles from your unit circle. Which 2 quadrants are we in this time? Yeah, our 3rd and 4th, because again, sine this time is our y values. So for our y values to be negative, we have to be in the 3rd and 4th. So we're looking at a reference angle of pi over 6 in our 3rd quadrant is going to be 7 pi over 6. And then in our 4th quadrant is 11 pi over 6. If you write them in degrees, I don't care. The reason why I like to write them in radians is because it's easier to like match the denominators, right? To make sure you have the correct angles. It's a little bit harder to do that with your degrees, but you can write your answers in degrees too. Either one is okay. What questions do we have there? Yes. No. Alright. Let's look at another one. What's different about this one? It's a tangent this time. Is that okay? So remember that tangent isn't necessarily on our unit circle, but remember a tangent we mentioned earlier is sine over cosine, so we still can use our unit circle to help us. So how would I get tangent by itself first? Be careful. You already have a positive 1, so we would need to subtract 1, so we get 3, then divide by 3, and we get 1. So in order for tangent to be 1, what has to happen with our sine and our cosine? Huh? They have to be equal, they have to be the same, yeah. And where does that happen at? Pi over 4. Okay. And where else is tangent positive?
5 pi over 4?
Yeah, in our 3rd quadrant. And so in our 3rd quadrant, with a reference angle of pi over 4, we have 5 pi over 4. What's different about this one? Okay, so again, we're trying to solve for x, right? So let's think back to like our pre-algebra days. So that has x's on both sides of my equation. What do we need to do? Get it on one side. Are we okay with that? And usually we like for things to be positive. So what might it be helpful to do? Add the sine of x to both sides, yes? So if I already have a sine of x and I'm adding another sine of x, how many sines of x's do we have? 2 of them. And then this is a very similar setup to what we've been seeing. What's our first step? Subtract square root of 2 and then divide by 2. Okay. So again, sine is is negative, so which of our two quadrants are we going to be in? Okay, and what's our reference angle for when does sine equal square root of 2 over 2? Over 4. So in our third quadrant, which one has a reference angle, 5 or 4?
5
Okay, and in our fourth? Okay, now we've just been listing our first two answers, yeah? How many answers did we say we could have when we were looking at our laser? Like a lot, yeah, right? Because we said what could we keep doing? Add 360. Okay, if we're in radians, what is that also? 2 pi. How many times are we allowed to add that? An infinite amount of times, right? Okay, so that would be a lot of answers to have to write out. Agreed? So if we're asked to find all solutions, the way that we do that is we say plus 2 in pi. Where in is just an integer, so like if I add it 1 time, right, I'm just adding 1 rotation. If I'm adding it 2 times, I'm adding 2 rotations, and so forth. So then that takes care of all the answers. So sometimes it'll just say like, solve the equation between 0 and 2 pi, or like solve it for the first rotation, and then you just have to list the first two. If it says find all solutions, we have to put the plus 2 in pi, because technically we have an infinite number of solutions.
You also say like plus 360 and
Yeah, so if you put like 30 degrees plus 360 degrees, and yeah, it would work the same way. You will see like we don't generally see that notation quite as often. Because like most of our textbooks and stuff use radians, but yes, it would still work. Alright, we're gonna go ahead and stop